Good morning. My name is Dr. Khan Arif Nafis. Uh, I'm here at Assistant Professor in University Polytechnic. Today my topic is Earth Magnetosphere. The sun causes widespread effect on Earth's environment, and most of the phenomena have their origin in processes occurring on the solar surface. In addition to the production of wide spectrum electromagnetic radiations, which includes ultraviolet rays and X-rays, the sun's outer surface, that is known as solar corona, is continuously being blown away from the sun to form a supersonic outflow known as solar wind. The huge difference in pressure between the solar corona and outer interstellar space is the main cause. The difference of this pressure is the main cause that drives the plasma outward, despite the restraining influence and force of solar gravity, which is very high. But this difference leads to this. This occurs at a such high temperature that the individual atoms are broken up into their constituent ions and electrons. This state is known as plasma state. The early investigations have shown that interplanetary medium in the vicinity of the Earth is not just empty space, but instead it is filled with high tenuous plasma, which is being continuously blown readily outward from the sun at speeds averaging 300 to 500 km per second. This plasma flow, that is solar wind, becomes supersonic beyond a few solar radii because of heating, compression, subsequent expansions. Because of this supersonic nature of the solar wind, shock waves are formed in front of planets. Like the Earth magnetic field represents an obstacle to the flowing solar wind, and when solar wind reaches to Earth, it interacts with the terrestrial magnetic field of Earth, distorting it to form a compression on the day side and very elongated tail on night side. Thus, the interaction of Earth's magnetic field and solar wind makes a cavity by confining one another within which the Earth's magnetic field is constrained. This region within which the Earth's magnetic field is constrained, it is known as Magnetosphere, and a demarcation line, a line which demarks the where up to where the magnetic field is there and where further there is no effect. This demarcation region line is known as magnetopath, that marks a boundary between the magnetosphere and solar wind. The existence of magnetosphere is very important since it shelters surface of planet from the high energy particles of the solar wind. The distance of magnetopath, this demarcation boundary, from the center of Earth, it depends upon intensity of solar wind. The solar wind varies in response to the changing condition of the sun. As a result, the distortion of Earth's magnetic field, that means the position of magnetopath and the size of magnetosphere, they also vary accordingly. Generally, the boundary of Earth magnetic field, that is the magnetopath, and the solar wind is about, it is 10 Earth's radii on the side towards the Earth facing to the sun, and while on the opposite side to the sun, the magnetosphere stretches far behind, means far behind to Earth, even farther than the distance to the moon. What happens when the supersonic solar wind, its speed decelerated to subsonic velocities as a result of interaction with the Earth magnetic field? A shock front, a bow shock, is generated. In this region, at the shock front, the bow shock, the temperature and density of solar wind increases abruptly. This magnetohydrodynamic shock, this shock wave, it is little analogous to aerodynamic shock wave in front of a blunt supersonic projectile. The region between the shock wave and magnetopath is called the magnetosheath or transition region. The presence of magnetized Earth's magnetic field, has very little or no effect beyond this transition region. In plasma, with this field as a in a gas, we might expect to find the waves that are similar to the sound waves. But the plasma is principally composed of charged particles that carry currents. So its electromagnetic properties are also very much important. But the plasma density, pressure are also relevant. So as a consequence, plasma waves differ from both waves, sound waves, and as from electromagnetic waves. Basically, what happens? The combination of mechanical forces which are present because of gas-like properties of plasma and the electromagnetic forces which are present due to the charged particles, the combination of these creates unique type of waves that are called magnetohydrodynamic waves, MHD waves, which differ from the waves found in natural dielectric media. These are the lowest frequency waves that occur in plasma. These waves, means this lowest frequency waves, have attracted considerable attention since last century. The study of ultra low frequency waves in Earth magnetosphere, these waves that also known as called as geomagnetic micropulsations or magnetic pulsations, they cover roughly the frequency range from 1 millihertz to 5 hertz. The amplitude of these ultra low frequency waves are sometimes large enough that they can easily detected on the ground. For this reason, these ultra low frequency waves, have been known from more than 140 years, long before the ionosphere and magnetosphere itself were postulated. Indeed, the early observations of ultra low frequency waves led to the first suggestion, means the mind will strike like there the electric current that must flow in the upper atmospheric region where these charges are there. The first observation of ultra low frequency fluctuations of magnetic field with amplitude of several hundred nanotesla were made on ground. These are detected by Stewart in 1861. PC34 is one of the type subgroup geometric pulsations are one of the group. These waves, MHD waves, and they are observed mainly in dayside magnetosphere. Many studies at a ground station data demonstrated that these PC3 pulsations dominate in dayside, while the PC4 subgroup pulsations where dominantly occurs near the dawn or dusk. In general, the source of these waves, the mechanism of their propagation by which they are registered at ground station, these are vague, not thoroughly understood, and still they are in debate. It is believed that these waves can be generated either externally or internally with respect to the magnetosphere. Most of the daytime micropulsation activity in PC34 range is thought to be related to the waves that are generated upstream of the bow shock by energetic ions reflecting off the shock and creating condition for the wave generation. This region, which is external to the magnetosphere, provides fast mod wave energy that may propagate across the magnetopath and with a small radial damping can cross the plasma path and penetrate deep within the magnetosphere. For today, this much is. Thank you. We will discuss in our next slide about the details related to magnetosphere and as well as some ultra low frequency waves and their subgroups and their production and propagation up to the earth. Thank you very much.